So now it's recorded. Today, yeah, so we almost finished the tutorial questions and all solutions there, all questions there, yeah. So let's see how some of the questions, let's revisit again one more time, all right? Please, guys, yeah, keep talking, hey, all right? Okay, so here you go. So what I do today is I want to just like, you have a quiz, right? Yeah, I'm not going to cover your lab work. So I'm sure you have done labs and you have watched those videos and the things that should be all good, right? But the questions related with the tutorials that can be in a quiz, some part of quiz is also those tutorials, and some part of exam also similar to mostly the exam is based on this, right? The test we are having, online test. So how they appear, can I just talk a little bit? They appear like this, and when you open the quiz, the question comes like this. For example, question number 11, and that's the problem. So you need to solve this problem, what they ask for. And what we need to do is
Mock test or like the lab quiz?
no, this is tutorial only. Lab, there will be like up to, this is starting from question 11 here, right? Did you see that on the left? So up to question 10 is like a multiple choice or those type of things in a lab-based concept. Did I answer all right? Okay, so now your quiz, you are going to have next week, yeah? That quiz consists of two parts, right? The first 10 questions are based on the concept you learn in the lab, like a direct share test, tri-Excel test, those type of general concept, not data. Nothing there about data, just the how, what we do in UU test or CU test, CD test, those type of things, right? Actual understanding of tri-Excel and share test, they are all multiple choice. Good, right? And then from question 11 to 13, there are 3 questions. Yeah, that's from tutorial. Why I put that things there is these are the type of questions you will be getting in test later on exam. Okay, is that clear now, Sandeep?
Yes, sir.
Okay, so now let's do those tutorial type questions now. Is okay? Yeah, let's do now. Yeah, start doing now. What you need to do is in the quiz or in the exam, whatever we call it, the test at the end. So the question appears like this in the quiz. This is not the same questions you will get, right? Every student will get different questions anyway. All right, mostly, right? Because they are randomly generated. So let's solve this problem. And then when you solve this, right, in the exam, remember, you need to write the stepwise process. Yeah, you need to solve it, show the calculations, and just put answer over there. All right, so let's try to solve this now. Come on, yeah. So do you have your resources with you now? Yeah, what? They're like a lecture note and things, because I wouldn't know those all equations, right? We need to look at those lecture notes and things, right? Yeah, let's start. Okay, so let's solve question 11 now. Okay. Can you read now that questions, what it says? Question number 11, you can write that. You don't need to copy the questions, all right? Just write question 11. Yeah, and then you start solving this. What do we need to solve?
So by using Tarzai, we need to find the
Okay.
ultimate value. Q equal to C and C.
Yeah, Jagi 1943 methods, right? That's how you write. Okay, you don't need to write those questions, right? Method, right? That's what we are following now. Okay. So now what is the equation? So I don't know. So what I need to do is I go to my lecture note, right? Yeah. I'm showing how you really do. Okay. So that's that one, teaching, that one. I want to open up the lecture note. I know this question is from bearing capacity, isn't it? Yeah. So I'll open the lecture note for the bearing capacity, shallow foundations and the bearing capacity. Okay, first thing is if there is no sketch given, you need to draw the sketch. All right, so that's the main thing, so that we understand if sketch is there, no need to draw anyway. That sketch is already there. Oh, what is that one? Yeah. Look at this now. So this is Terzaghi method. So I can go straight to the Terzaghi. You can't just check over there, guys. You need to ready where the information is and where the equations are. You need to be ready beforehand. All right. Yeah. So let's do one of the Terzaghi one. All right. Yeah, is that one? No, there is a one that formulas there, all formula together. Did you see this now? So let's write. What is the one? The first one we are trying to solve, right? What is the Q ultimate? Please copy that equation, right? Come on. Q ultimate. You need to check from your book also if you can't see clearly here, all right? Can I show that now? Up there, okay? Okay, can I write that now? What is Q ultimate?
CNCSC plus Q bar and Q plus 0.5 gamma P
Maybe,
and gamma.
maybe it's good to draw the diagram also, right? So that we know what we are calculating, isn't it, right? How much is that? Let's do the question first, right? That's a 0.6, that's a 0.6. Diagram is okay, right? Don't write the copy questions at the top, but diagram and the summary of the data is good. Okay, so that's a 1. What type of footing is this? Squared or what type? Square footing, right? At the beginning it is written, all right? Okay, so now the swell C value is, how much is that? 13.4 kilo Newton per meter square. Yeah, what else is given? So water table is 15 meters below, so somewhere there, right? Yeah, very long way down, 15 meter. What else is there? Nothing, right? Yeah, so gamma is, how much is that gamma? 19 kilonewton per meter cube. And then angle of friction is phi equal to 30 degrees. Good. Just write a sketch, write a method. Oh, sorry, this is question 11, right? Where did that gone? I had written that. Yeah. You need to have question number, all right? Okay, otherwise we wouldn't know. Oh, okay, so like, can we copy that formula now? Just leave that now. CNCSC plus, that's a gamma D, right? Q bar means, yeah, gamma D and Q. And then plus half B and gamma, yes, gamma, yeah? We wrote the equation now, right? Let's do it. So 4 phi equal to 30 degree. What is the NC, NQ, and gamma? All right, we need to write those numbers. So now we will take a table. Did you see there? There is a table 4.2. Yeah, can we go there? To check what is the table? Yeah, 4.2 table is that, right? How much is that? Tell me now. Hey, it's gone. My sensor system is a little bit tricky. Yeah, my tap sensor. Yeah, that's one I want. Come on, how much is NC?
37.2.
37.2, 37.2, and NQ?
22.5.
22.5, and gamma?
19.7.
19.7, right? But you write here as a table 4.2, right? Is it good? Yeah, reference also all right. It is all good now. So what we need is, now go back to the equation again. Yeah, because we need to see the equation already there, but there should be some correction factors there. Yeah, did you see that? Yeah. So for square footing, SC equal to what? SC equal to 1.3.
1.3.
Yeah, so S gamma equal to 0.8, right? Yeah, so table, what, 4.1, yeah? We take from table 4.1 that type of information. Good. So now you substitute here. So Q ultimate equal to, so C, how much is C? 13.4, yeah, times how much is NC? 37.2, times what is SC? Is 1.3, plus gamma is 19, times depth is 0.6, yeah? So times NQ is 22.5, yeah? So now what? Plus half Gamma is 19 times B is width is 1 meter. Yeah. N gamma, what is N gamma? 19.7 times what? Yes, gamma is 0.8. Can you put that now? Put in your calculator and give me the answer, please. Yeah. How much we got?
Sir, for the
912.4.
quiz, we need to upload the solve answer sheet also.
No, not for this next quiz, only for exam.
Yeah, we need to only for exam, yes, sir.
Yeah, only for exam. For quiz, just the answers. Finally, answer should be enough. All right. Okay. How much you got? Yeah.
912.4.
912.4. Is that correct? We got I have slightly different here. Just need to check. 13 point. Can you check other people also? Confirm. No calculation mistakes. Half B is 1, gamma is that, and gamma, yes, gamma, that's all right. That's a 19.6, 22.5. That's one, right? 37.5, 30.4, and 1.3. Should be all right, but I need to check that. Other people also got, yeah? Same? Please calculate. Yeah, I don't have calculator. Come on, yeah. I have slightly different answer.
Why
here.
there's two 19, sir? The other one is 19 and 19.7.
I think 19.7 is N gamma. 19 is gamma.
It's
Oh, there is
okay,
a
sir.
gamma.
It's okay. Yeah,
Oh,
gamma.
sorry. Yeah, there is a gamma.
I forgot that gamma, sir.
Oh, okay. So there is a gamma there in the formula. I think I didn't. Oh, yeah. All right. Yeah, that's okay. Yeah. So just try.
It's 1054.24.
Yeah, that's what I have here with me. All right. Yeah. 1024.24. 24 kilonewton per meter square.
54, sir. 1054.
54. Is that 54? Yeah, 54, correct. Okay, so that's the correct answer now, right? What you need to do is now, I'm talking about for the quiz, just you get that answer and then go in the quiz and just put that one here, just the number, okay? Don't put kilonewton per meter square thing. Make sense? We will use standard unit. Just put there 1054.24. That's it. Is okay? But for the exam, similar questions come in the quiz, but you need to scan this now, you're working, and upload. Does this make sense for all of you guys? Yeah?
Yes, sir. And sir, other question is like, how much time we get for this upcoming quiz?
Upcoming quiz, I gave you 4 hours. Okay. So, but you hardly take, because up to 10 is just multiple choice, right? Yeah. So it's just 3 questions. So you will finish less than 2 hours time.
It's 4 hours, yeah.
The total is 4 hours, 5 to 9 in the evening. I have provided, yeah. But again, just try to do it first, yeah, and then redo again. I have allowed 2 times, 2 attempts. Is it okay? So you can do two times, and so whatever you get the best first time or second time, first attempt or second attempt, then I take the best of marks for both. But you have total of 4 hours to do both. Yeah, it's okay. If you get good marks in the first go, you don't need to do the other one. You know what I mean by, yeah? Any other questions? No, very clear, right? Very easy, right? Yeah, so that's the load. So that's it. That's done. Can we do now question 12? Question 12, right? That's the second question. There is no sketch. Yeah, so it's better to sketch that. Make sense, right? Yeah, let's sketch. What is that? Estimate the ultimate pile capacity. So it's a pile foundation. Good. 300-meter round concrete pile. That is 26 meters driven into the soft clay of that. You see now, how long is the pile? 26 meters, right? From here to here is 26-meter pile is a clay, right? Yeah. So where is water table? Water table is 2 meters above the ground. Water table is somewhere there. So all submerged are effective gamma. So gamma dash is given there, 8.15 kilonewton per meter, already converted, right? You don't need to minus 9.81 because effective or submerged unit weight is given there. Is that right? So QU is how much is the QU? 18 kilopascal, kilonewton per meter square. But from QU, you always convert into CU or SU, whatever you use in the formula. It's a half of QU. Okay, so that's what the unconfined compressive strength is, right? So that means the 9 kilonewton per meter square. Now we know the C value. Good, yeah. So what is the diameter of this one is a circular, yeah. Round is circular, so diameter is 0.3 meter. Always using meter and a kilometer unit, all right? So that's QU that, and that's it. So what you need to find, what is the ultimate capacity of this pile? How much load this pile can carry? Q, total Q. So it will carry some part by the tip, right, at the bottom. Some part by what? Shaft, yeah? Skin. Good, right? It's a clay. So now easy. So what? Q total would be what? Q point at the bottom plus Q at the shaft, right? Or friction, whatever we call it. It's got it, yeah? So let's go a lecture note and have equations for that. We wouldn't remember those equations, right? So go to the lecture note and then so lecture note is what? 3-4, right? Deep foundations and the piles. All right. Let's open. So what methods are they specified here? Lambda method, right? Yeah. So let's go and use the lambda method, right? So what is the lambda method? There are a lot of resources provided, but the different authors, but they will get the same result anyway at the end. What is lambda? Basic that and that. Okay, that's the gen. This is a point capacity for. Oh, point is easy, right? Yeah. Oh, well, at the bottom is I think 9 SU is this one. Yeah. Did you see that? Pulse in saturated clay here. So QP is what? 9 CUAP. All right. It's good. So I can write that, but everywhere you have the same thing, right? If you see another author, that's the same thing. Did you see this at the bottom? 9 CUAP. And then you can see all others, everything is same from all authors, same equation, right? So let's use this one, right? Maybe it's better to Bowles method. Where is the Bowles one? I want to use that. Point capacity I'm talking about, right? Point capacity, and then it's a saturated clay, right? Because it's a clay underwater. Oh, that would be the easiest one, right? Okay, so now, can I go back now? Oh, what is that? Yeah, so now QP equal to, let's calculate QP first. Yeah, okay, QP equal to, for saturated clay, what is that? 9 CU, area of the point at the bottom. Come on, so 9, what is the CU value we calculated? Tell me, please. I can't just talk. You need to talk, come on. How much CU?
9.
9, right? So area of the base is around. So what? Pi d squared divided by 4, isn't it? Can you calculate for me? Point capacity we got, right? Give me the value.
1.27.
How much? Sorry, say again.
5.72, sir.
2772.
72.
72 kilonewton, right? Because it's already kilonewton, not the pressure, it's a load, right? Total load. Good. So now QS. QS are the different 3 methods, right? Alpha, beta, and the gamma methods. But in this question, they have asked gamma, yeah? All right. Let's go to the skin capacity. Not point, but the skin. Skin, right? The pile skin capacity. This is not alpha. What we want is lambda method, yeah? is the lambda method. Did you see that? How easy that is, right? So can I calculate now? So it should be friction times area of the shaft, right? Yeah. Friction S times area of the shaft. Okay. So what is the formula? Lambda. What is Q bar? Which is gamma D, right? Yeah. Plus 2Cu. That's Su is Cu, right? Did you see that here? I wrote that there. Yeah. So times area of the shaft. Okay. So what is lambda? How we get lambda value? Either read here. Oh, that's is there any other better table or graph from any lambda methods? I can check. You see lambda methods there. Okay. That's the lambda value, but it still is a lot of the graph reading. It may not be accurate, right? And we keep going to see alpha methods that, and that's a beta methods. What is lambda? That's it. I want to see some tables or some values that gives correctly a lambda method. Yeah, that one. You see, there is a table here. Do you get it? Yeah, how easy it becomes now. What we need to calculate now? Oh, come on. Yeah, check. That's the reason why I provided many authors, right? References to see what is the easy to calculate lambda values and so on. All right. Yeah. So what is lambda here based on how much embedment? All of it, right? 26. Embedment L, right? Yeah, that's it. So L is go down to 26. Where is 25? Yeah.
24, sir.
So 25 is what? How much is it? 0.14? 15? Did you see that there? Yeah. Length of embedment is how much is going in piles down. So now, so it's 0.25 is that, and 30 is 0.3. So it should be about. It is okay to assume also, or you can interpolate. Okay, that's up to you. If you have time, why not interpolate? If not, then it looks like there is a 5 gap here, 25 to 30. And then we get 1 gap. So it must be very close to 15, right? Can I write like a 0.145? Make sense? You can interpolate to get exact, okay, if you want, right? But it is okay to just to have a look and then get some values. So what is Q bar? What is the average gamma D? Gamma, how much is gamma? 8.15 times what is the depth? Usually we take average of all, so its center value is good enough, right? Is 13, right? Average friction along the shaft means we usually take in the center, all right? So plus, hey, what is my mouse? Plus, what is the other one? 2, what is Cu? Cu is 9.
9.
Yeah, so now can we calculate the area of the shaft now? Oh, look at this. When I toss that, it goes. So it's better I use mouse to remove that, all right? And I click that too, okay. That makes better sense now. So times AS, what is the area of the shaft? Length is 26. What is the around is pi d, right? Circumference is pi d, isn't it, right? Pi times 0.3. Can you compute this now for me? Oh, by the way, when you write that lambdas, you need to provide table, right? Just write table or equations, table 11.9, okay? That
24.
how much you got?
Oh, no.
Not it? All right.
So it's 677.6.195, 196.
How much you got?
677.6.196.
Oh my God, that's a very big one.
Yeah, I think that I made somewhere mistake, I think. Oh, yeah.
Is it 440, sir?
Yeah, 440.
Yeah, that looks better. Yeah,
I
because
made
it's too big. Okay.
440.41.
Yeah, that's a lot better sense now. All right. Yeah. So can I write that? Okay, so that would be, so I want to click that first. Yeah, or maybe that one. So 400, what you said? 400? Please tell me.
440.41
41, right?
for
Kilonewton.
1.
Now total would be what? Just can you add them total together? 5.72 plus what? 440.41, 440.41 equal to 445, yeah? 445 point. How much is that? The
446.13.
13, right? That's it. Kilonewton. So you go there and just input that value there. Makes sense, yeah? Easy, isn't it, right? So please follow the lecture note. You need to try a few times this. That is the reason in the quiz, I gave you a lot of hours, like 4 hours to complete. The reason is you need to look the resources and study and do stepwise, okay? My answer also very close to that. So answer also is not exact. For example, over here, if correct answer is, if you calculate correctly, if correct answer is like a 450 kilonewton, I'm just giving example, right? The answer from anywhere like a 320 to 370 around, right? That should be correct, right? That because you know what? Because this value we take from table sometimes slightly different, isn't it? So the system itself, it considers answers are correct in the some range, like a 5% or 2%, like this, depending upon the type of problem. It's okay. Don't worry about calculating exactly to get correct, right? If there is a range of answers will be correct. Okay, but not big range, not like a 20% up or down, right? Which is too much, isn't it? Yeah. But at least some, there is what we call it little bit error in the computations, right? We can accommodate that in the system. How you feel? All good?
Yes, sir.
All right, let's do the third one, right? I think we will finish by doing that. I think you know now how the questions appears and how you do these things, yeah? So
Sir, you have uploaded the lab data also, yes, sir?
already there.
Yeah.
But lab is, I give you 1 more week after the quiz. So it should be all right after you do quiz and this practice.
Sir, this is on 23rd, I think, and the lab report is also in 23rd September.
Are you sure?
Yeah, sir, I checked. You can just check, sir. This.
Have you checked just now?
Yeah, sir, I've checked like 20 minutes ago.
Oh, okay. I'll check. I'll give 1 more week, right, for lab report. Is that right? Yeah. Do the quiz first, and this problem like the quiz, and then you'll get about a week. Is that okay? I'll see that now. Let's finish this, and then we'll check that. Is okay? Okay. Question 13 now. What is this now? It's a lateral earth pressure theory. Yeah.
So it's 30 September. It's okay, sir, now.
Yeah, that's all good. I think I have given you 1 more week. I know that.
Yeah, sir. Yeah. 23rd September is a quiz, and then 30 September is lab report.
Yeah, 1 more week. Yeah, that's true. Good. All right. So what is that? It's a wall. Did you see the heads? Right. That's the total height of the wall, which is given at the top, right? 7.5. Can I draw the diagram now? So this will be from here to here is how much is that? 7.5 meter. Yeah, because that's written. Please read and then sketch the diagram. And from the top is 4 meter down is the clay layer. How much will be the bottom part now? 3.5 meter. So that's the clay layer, right? Yeah, that's the clay at the top. Good. So clay layer, all properties are there. You need to write all those properties first, right? C equal to what? 10 kilonewton per meter square. I wouldn't say clay, but it's like a C5 soil, right? Phi equal to how much is that? 30? Yeah? Degree? Okay. And then what's the gamma 1 value? The first layer, that's the gamma of the top layer. How much is that given? Can you read? The upper clay layer is 4 meter thick with cohesion is 10, angle of friction 30, unit weight 16.4. 16.4 kilonewton per meter square. Good. We got the first layer. How about the second layer? Is is a sand, so C 0, right? Phi is, how much is phi? Can I write 1 here? Phi 2. Second layer friction is lower sand layer, has the angle of friction 36 degree. All right, the C0 by the way, and then saturated unit weight. Water table is here. All right, gamma sat equal to, how much is that? 18.5. That's the second layer. All right, kilonewton per meter cube. Yeah, so we need to determine the total active force per unit length of the wall after tensile cracks. After crack, there will be a tensile crack here. Why? Because it's a clay at the top, isn't it, right? First, we need to find how deep the crack would be. Yeah, how deep the crack would be. That's why we call it crack there, because this will be diagram is coming in the negative side based on the equation, and then calculate the active force. Is that clear? Question is clear, yeah? Let's go and open up the earth pressure theory. All right, so active force. So we can, because wall is vertical, we can use Rankine's theory, right? So let's go to check the Rankine's theory now. Easy, right? That's it. Yeah. So at the top, let's draw the pressure diagram now. Pressure diagram at the beginning, this side is what? Negative. At the top is what? Sigma is 0, right? Yeah, that value is 0, means negative 2c root k. Oh, we need to find. Can you calculate k for this layer, please? Yeah, okay, I'll use another color, right? Active force means k equal how much that? K equal how much that? Come on. Ka1 and a Ka2, we need that. So Ka1 equal to what? 1 minus sine 30 divided by 1 plus sine 30, right? Where is written? Yeah. Did you see the equation there? How much is that? Is it 1/3?
Yes, sir.
Is it? Yeah, 1/3. That's done. So how about the second layer, 36? Ka2 equal to 1 minus sine 36 divided by 1 plus sine 36. Give me the decimal places, this one. Yeah.
0.26.
0.26. Good. Yeah, we got Ka. So that's, oh, I don't need to write this. It will be overcrowded. So I'll just remove that, right? Okay. Something gone. Oh, here you go. Yeah. I want to use my mouse to see because it's becoming a little bit more sensitive. All right. We got that. So let's draw the pressure diagram first. We need to be careful here, right? Let's draw the vertical line first. Yeah. So at this point, that side would be what? Minus 2c, that part, 2c root Ka. How much is that? Can you do that now? So minus 2c root Ka. Can you do that compute? Because you know the Ka value for the top layer. And also you know the C value, how much is this part would be. Come on.
$11.55. Negative 11.
Negative, right? So 11.55,
Yes, sir.
that part, right? That part. Good. Okay, that's done. So now we have this depth of tensile crack. Can you calculate that from that C? ZC equal to 2C dash. Oh, that's the C dash, same thing, effective. So gamma root Ka. How much it will be? 2 times C is how much? 10 divided by gamma is 16.4 root over 1/3. How deep the crack would be? Can you calculate for me? Whether it will be within 4 meters or more. I need to check that first. Yeah.
2.11, sir.
Oh, 2.11. So it falls, it's a meter. So it falls within this area, right? Yeah. Did you see that? That's the tensile crack. That means over here, that value is 2.11 meter. Makes sense, right? So now what will be the pressure at this point? This point. just above the layer, right? Just above the layer, right? What happens there? So over here, how much is that? So just use that equation. Sigma dash, how much is it? Gamma is 4 meter, right? Yeah, 4 meter times 10. Can I just calculate here somewhere? So now sigma A dash at 4 meter. Sorry, I'm writing a little bit differently here. You need to show calculation stepwise, all right? Not like randomly everywhere, right? Yeah. So that would be what? Sigma dash Ka minus 2c root Ka. Can I do that now? What happens here? That will be gamma D. Gamma is 16.4 times D is 4 meter times Ka is 1/3 minus 2c. 2c is 10. Root Ka is how much is Ka? 1/3, right? Can you compute this for me, please? That value, yeah. It's a multiply here, yeah. How much you got? 16.4 times 4 times 1/3, take away minus 2c dash root over 1/3. It should be positive because already tensile crack is there, so I need to get that value. How much?
10.32, sir.
So 10 means little bit lower than 11, right? So it's, yeah, that's fine. So that's value is from here to here is 10 point. It's a positive, right? 10.32, yeah. Good, yeah, kilonewton. I think kilonewton per meter square. You need to write unit. I don't have enough space here, all right? So that's why I'm fixing that. So now I got it. How about just below? Just below the layer, at this layer, just below, there will be no this C part, right? Yeah, so there will be a pressure is same, that one is same. So can I just show you now? Can I delete this part? Remember this value, all right? K value, I want to calculate. But in your solution, when you do, you need to have all stepwise calculations. Can I do the pressure at the bottom here? Now, how much it would be? So gamma D is how much is that? Gamma is 16.4, same weight at the top, times depth is 4, and then multiply by Ka. Ka is, I need to use the bottom Ka. How much is that? 0.26. Can you calculate that for me? There is no C for the bottom layer, all right? How much is this? Less than 10.32 or more than? I need to know that. Maybe less than, yeah. Oh, maybe more than, I don't know. Please compute.
$17.06, sir.
17.06 kilonewton per meter square is a pressure diagram, right? Yeah, it goes far, right? Because that was 10 only, yeah? So over here, it goes total is 17.06, yeah? What will be at the bottom now? Easy. Just calculate the pressure, yeah? Total pressure at the bottom, yeah? What happens here? Can I write equations here? So what? 4 times 16.4 plus what happens the bottom one? 3.5 times. So 18.5 take away 9.81. Can you calculate that? And you need to multiply these all by 0.26. Yeah, that's the K2, yeah? Because it's no C, so it's very easy. Come on. Can you calculate that? 4 times 16.4 plus 3.5 times 18.5 take away 9.81. And you multiply by 26.26. How much? Come on, guys. Hey, you are so many there, so you can calculate. So 4 times 16.4. Yeah, plus 3.5 times bracket 18.5, take away 9 point, oh, not that one, 81. The total is that, multiply by 0.26. Did you get this? 24.96 or different?
Same, sir.
Okay, same. So 24.96. So now we just connect that. You see, so easy, right? There are two parts there now, one triangle and one that. And then there will be a water, right? Because there is a water table in the center. Don't forget that water pressure. Yeah, okay. So that means how much is the bottom one? Gamma W is 9.81 multiplied by 3.5. How much is that? 9.81 multiplied by 3.5, yeah? Gamma W, right? 34.34. 34.34. I gone to next page, right? Yeah, 34.34 here. 34. Good, yeah. 34.34. Done. So we have all the pressure diagram. What it says question, read question carefully, right? After the tensile crack develops, what that means? Who can tell me? So you need to ignore the value above the tensile crack, all right? So what that means is, oh, something coming. All right, okay, so now what that means is, you just ignore that part. Don't consider this, okay? Calculate this area now. That area 1, this is area 2, that's the area 3, area 4, and then add them together. Can we do that now, please? I want to just remove this, the previous writing, and then I'll just remove that first. Yeah, all of them. It takes a long time to delete this. Hey, that's just a moment. Yeah, any questions? No, now area 1. Can you calculate area 1 now? That one half base, how much is base? 10.32.
32.
Height is 4, take away that, right? From the top, isn't it, right? 2.11. Can you calculate how much is the first area of this part?
9.75.
9.75. Now it's kilonewton, right? Because we already converted into force. How about number 2? Number 2 is this, so 17.06. So that's a 3.5 times 17.06, right? How much is that? I'm calculating area of the rectangle, that's it. Maybe 60 around. I don't know.
59.71.
59.71 kilonewton. We got that. So area 3. Oh, for area 3, I need to calculate that side. That side is 24.96. Take away 17.07. How much is that part? Can you give me that one day? 24.96, all of it, right? So that take away the top one. Yeah.
7.9.
How much?
7.9.
Okay, so half times 7.9 times what's the height? 3.5, yeah? Half base times side, area of a triangle, yeah? How much is that?
13.83.
13.83 kilonewton. All right, so now water remaining. Water is easy. Half base is what? 34.34. 34.34 times height is 3.5. Can you do that for me?
$60.09.
60.09 kilonewton. Oh, that's the water pressure is the highest. Can you hear them all now? because total active force, isn't it, in the wall?
One 143.38.
143.38, right? Yeah.
Yeah.
How the system it shows here is 143.25. You see, that's just the decimal thing, right? Yeah. So of course, there will be a range of values correct, maybe from 140 to 145. You understand what I mean? So there is a small, the decimal considerations is taken into account when you have those. So this is a correct answer based on what I have here. So what you need to do is after you do those all, just put the answer here. Okay. I want to say again clearly, right? For the next quiz, you just put answer here. You don't need to show this workout. Okay. So no need to upload. But in the final test in October, you need to do this, write the answers here, and also you need to show the workout here. Remember, whatever you have worked out, answer here must match with the submitted answer. This is because sometimes we make some small mistakes in calculation. Yeah. In that case, we can give some marks for the process if we see something, isn't it? Yeah. Like a pressing calculator, you get some marks in the process. So that's the reason why I want you to upload that. How is it? Easy, yeah? Looks easy, isn't it? All right. So now, another thing is, how I know these questions, what type of questions I get? Who can answer? Here. Same as tutorial questions.
All the questions are same.
Yeah, all we did tutorial questions, these all types. Yeah, you know the tutorial, the questions we did? Yeah, all these types are there. Just values different and some combinations. So there is nothing new there. So what you need to do now is you know how they appear, right? The questions. So you need to go back and revisit all those tutorial exercises we did over the first 7 weeks, 7 or 8 weeks. For this, I think only a few weeks only, right? Because like what? It looks like one up to lateral arch pressure theory only quiz, but exam, it comes all from up to week 8 tutorial questions. Enough. I think my job today, I wanted to make sure you are not scared of the questions, all right? So when you get the quiz or something, then look at this. This is just 10 marks quiz. This is 2.5. That's a 2.5 and that's 2.5. How much is that? 7.5, yeah? All 7.5 here. So multiple choice questions before this is considered like a 2.5 total, yeah? That's why, that's up to you, how you do it based on your understanding. How you prepare, there are videos talking about what is triaxial test, what is consolidation drain, okay? Consolidation and a drain. Unconsolidated on drain, consolidated drain, the drain on consolidated. There are UU, CU, those type of tests. You need to, and direct shear test, I think you are very easy to understand that, right? The normal force, yeah, shear force and normal force. So you need to get that idea. I have uploaded a lot of videos for you to understand the concept. Before going for the quiz, please review those videos for the concept, but these problems are from your tutorials. I think I have helped a lot. Yeah, that's it now. So what we do is maybe, right? Yeah, next week, like this in the evening, yeah, do a few tutorial problems again, right? From the later part, not this part, right? This part is done now. They're like up to week 6 is okay. But week 7 and 8, we will do 1 or 2 tutorial questions next week, and we will finish by next week. Okay, then after that, only if you have any questions, then I can answer, right? Yeah, during the process, otherwise it will be all done. So remember now, few things. Please submit your assignment too, I think this week, huh? And then do quiz next week. And then do the lab report by another week. And then you will have 2 weeks time after that, preparation for exam, okay, or test. So I'm sure you have plenty of time to focus on this and do your best, all right? Yeah. So today I finish. If you don't have any questions, anybody has?
Oh, sir. Sir, I think that we need to repeat the retaining wall questions once again.
Yeah,
Some
repeat-
questions we need to
Yeah,
go.
correct. Retaining wall is part of this anyway, right? There are retaining wall design. You are right. Yeah, thanks. I'll do that. Yeah. So I'll do that a few times, right? But depends on next week. Let's do few other tutorial problems like this calculation. Is that right? Yeah. So how about any other students? Any questions for me? No? Okay. So okay, best of luck for your assignment. There are a lot of work to be done by you guys now because you need to submit the assignment to do a quiz as well as you prepare the lab report. And so that's why I don't disturb that much by teaching too much. I do some tutorials like this in the Wednesday evening. I'll come on Monday next week. Yeah, Monday is we will finish our lecture also on Monday. Okay, so then we'll do few revisions on Wednesday evening. That should be fair enough for now. All good. Any other
Okay, sir.
questions?
Thank you, sir.
Yeah. Any other questions? No? Okay. Then yeah. Please see you on Monday morning in the lecture.
Okay.
Thank you, sir.
Thank you, sir.
Bye.
Thank you.
Yeah. Bye.
Thank you, sir.